friends, welcome to my YouTube channel Echo Aftab. In my today's session, we are going to deal with number system. Myself, Aftab Bhai. So friends, let us start with from where the numbers have come from. Origin of numbers. The origin of numbers date back to the Egyptians and Babylonians. So they knew the numbers such as 1, 2, 3, 4, etc. Then later on, the Greeks at the time of Pythagoras discovered the concept of irrational numbers. I hope you know Pythagoras, a very famous theorem called as Pythagoras theorem, that is, he is from Greek. So moving ahead, the number system evolved during the Middle Ages with a very important contribution by India, that is a convenient notation of zero and negative numbers. The biggest contribution of India to our number system is we have given to the world the number zero, because of which counting became easy and even the concept of negative numbers came into the picture. Then friends, the properties of the real number system, consisting of both rational and irrational numbers, began to be understood in the 1600 with the development of calculus. So in the introduction slide, you can see we are making use of something called as positive rational numbers. Then we are speaking about negative numbers. We are speaking about real numbers. So what are these numbers actually? Let us flow with the numbers very quickly. Now, before that, I would like to show you all from where these numbers have come. As I said, we are speaking about Egypt and we are speaking about Babylon. So, where actually this Babylon is, I would like to show it to you on the map of the world. So, here is the map. You can see the circle. So, these two circles, or you can say the two places, Egypt and Iraq, have given birth to the number system. So in Iraq, you can see one particular place, Hilla. That place is called as Babylon. So friends, these are the places from where the numbers have originated. Later on, it has been developed and evolved over a period of time, different countries contributing in their own way. Now moving ahead, when we speak about number system, there are what actually is number system? A number system is a system representing numbers. It is also called a system of counting, and it defines a set of values to represent a quantity. Earlier, how the numbers were done, friends? The numbers were counted something like this. People used to count the numbers as like this. So they used to give the markings. And later on, we came to know in our schools about 1, 2, 3, 4, 5. This is frequency distribution. In few places, they used to draw something. They used to draw this type of images to count. So the origin of number system is as old as the civilization has started. So, but how we are presenting these numbers, that is what is our number system. It also allows us to operate arithmetic operations such as addition, subtraction, multiplication, and division. It is possible because of these numbers that we are able to go on for arithmetic operations. What do you mean by number? Friends, when we speak about the word number, a number is a mathematical value. It is having some value, and it is used for counting or measuring, or you can say it is a notation. Every particular alphabet and number that we write, it is a notation which gives some meaning to what we are saying. So number is a mathematical value used for counting or measuring or labeling the objects. So friends, numbers are mathematical notations to express the value. If I write this thing, if I write this particular notation, you will say it is number 1. If I write this particular notation, you will say it is the number 2. If I write this notation, you will say number 6. If I write this, this is also notation which is implying the alphabet. So friends, numbers are mathematical notation which is giving a special value for every is mathematical. So having understood what do you mean by number and number system, let us move ahead and see what are the different types of numbers. So friends, these are the different types of numbers. In my today's session, we are going to understand all these numbers. What do you mean by natural numbers, whole numbers, integers, rational and irrational numbers, real numbers, prime numbers, imaginary and complex numbers. So by the end of this class, you will be able to easily identify which are the different types of numbers, and when you are calculating or using arithmetic operations, definitely you will know you are dealing with which type of system or which type of numbers. Moving ahead, one by one, let us pick up what these numbers are and try to see how we are going to make use of it. Let us start with natural numbers. Natural numbers are counting numbers. So these are the numbers where we start counting it on our fingers. They do not include 0 and they do not include negative numbers. Naturally, when we are able to count, those numbers are called as natural numbers. And as you know friends, we cannot count 0 or we cannot count negative numbers. So that is the reason natural numbers are called as counting numbers. So on a number scale, how do you represent the numbers, that is the natural numbers? They will be in a set of natural numbers. It can be written as 1, 2, 3, 4 up to infinity. The numbers can go up to 10, 100, lakhs, thousands, crores, billions. All this will be the set of natural numbers. So on the number scale friends, the numbers are 1, 2, 3, 4, 5, and this goes on. This list goes on and on. And here you can observe one thing. I am speaking about all the positive numbers. So here we are speaking about plus 1, plus 2, plus 3, plus 4, plus 5. This goes up to positive infinity. So all positive numbers are natural numbers. So the first type of number that we understood is natural numbers. All positive numbers are said to be natural numbers. Then we'll move one step ahead. We'll see what is the contribution made by India to the number system. That contribution makes the number a whole number. So whole numbers are also natural numbers with 0. That is, whole numbers along with the natural numbers, they include 0. So W is equal to 1, 2, 3, 4 up to infinity, which also includes 0. So a set of whole numbers can be written as 0, 1, 2, 3, 4 up to infinity. So on a number line, the earlier numbers will be there, 1, 2, 3, 4, 5. These are all natural numbers. When you bring 0 in this number line, all positive numbers along with 0, you can see here the yellow mark, we have introduced 0, and when this particular set along with 0 becomes whole numbers. Natural numbers is without 0. When you bring in the set of numbers 0, then those numbers become whole numbers. Then friends, the next is integers. So what are integers? It was Abermarth Holst who invented the integer number system in 1563. Integer is a Latin word which means whole or which means intact. Whole or intact matlab which is not in fractions. So friends, integers include all the numbers which are positive, which are negative, and also 0. So integers include positive numbers. Positive numbers matlab natural numbers. 0 means whole number, and we are bringing into the picture a new set of numbers, and that is our negative numbers. Here you can negative. So integers do not include fractions or decimals. As I said, the meaning of the word integer in Latin is whole, and when fractions come, matlab it is in pieces. So a set of integers can be written as z is equal to -3, -2, -1. So here you can see, friends, this particular set 1, 2, 3, 4 up to infinity are our natural numbers. When you bring into the picture 0 along with the natural numbers, it becomes our whole numbers, and this along with negative numbers, if you are counting, if you are calculating, this becomes our integer. So one by one, when we are going on adding up different set of numbers, we are moving from one type of number system to another type of number system. So on the number line, these are our positive integers, which are also called as natural numbers. Now this set has become set of whole numbers along with 0, and when we bring into the picture the negative numbers, we are into integers. So a set of positive numbers and negative numbers along with 0 are called as integers. So this is the way number systems have evolved. The different types of numbers have come into the picture. So Abermouth Host was a person who invented integers. Moving ahead, having understood what is natural numbers, what are whole numbers and integers, we will move into a different area that we often come across in our day-to-day life, and that is rational numbers. What do you mean by rational numbers? The word rational is originated from the word ratio, and you know, when I speak about the word ratio, here we are speaking about two integers. Rational numbers are related to the concept of fractions which represent ratios. Rational numbers are written in the form of P by Q, and here, friends, one very important condition for a number to be a rational number is the denominator Q should not be equal to 0. So example of rational numbers, I can say a set of rational numbers such as -2 by 1, -1, 0, you can say half, you can say 3/4, or you can say 1 by 1. All these things constitute to be rational numbers. So every natural number is a rational number. When we say whole number, that is also a rational number. Every negative number is also a rational number, and along with all these numbers, the horizon of rational numbers widens up, and even the fractions that we write comes under the category of rational numbers. So friends, on the number line, you can see what is the number line of rational numbers. So the pink dots are telling us about natural numbers. The yellow dot is telling us about whole numbers. The blue dots are telling us about negative integers. So till the previous slide we understood this. Now where does this rational numbers come into the picture? So these are all intact numbers. These are all, you can say, wholesome numbers. Now if you divide these numbers, one number with the other number, then you will get what we call it as the ratios, that is the fractions. So friends, this particular red dot that has come, this red dot is in between 0 and 1. So it is not an intact number, it is a number which comes in fractions, and that is half. So 1 by 2. So here, as we have written P by Q, you can see here P by Q. So here 1 by 2. 1 is also an integer and 2 is also an integer, and these two integers are written in the form of fraction or ratio, then it becomes rational number. So half is one example. This side if you see, minus half is also an example of rational numbers. This side one more red dot has come. 3 by 2 is also an example of rational numbers. 5 by 2 is also an example of rational numbers. Normally, one more example that I can give is just here. So, if I see this particular red dot at this point, you will get 3 by 4, 3/4. So, friends, this half, 3/4, 3 by 2, 5 by 2 or minus 1 by 2, these are the numbers that come along with all the previous numbers that we have studied. So friends, this numbers minus half, half, 3 by 2, 5 by 2, if we are counting these numbers along with the previous numbers, then we call all these numbers as rational numbers. So rational numbers means a set of natural numbers along with 0, along with negative numbers, and along with all the fractions. So all this together becomes rational numbers. Now, how do we make use of these numbers with our arithmetic operations? How can we interpret these numbers in terms of pluses and minuses? Now, you might be curious to know if we add up natural numbers, what numbers we can get, or which particular mathematical operations, arithmetical operations we can make use of. So, one simple example, if you add up all the natural numbers, that is, if you add up a number, let us say 2 plus 2, 2 is also a natural number, and or 2 plus 3, and 3 is also natural number. So you are going to get one more natural number. If you add 1 plus 11, you will get one more natural number. So addition of natural numbers, by adding two natural numbers, it gives us the answer will be also a natural number. So friends, addition of natural numbers gives us a natural number. What about subtraction? So subtraction of natural numbers, what will happen? If I say 10 minus 5, it is 5. If I say 2 minus 1, it is 1. If I say 2 minus 3, what it is? 2 minus 3, 2 minus 2 will be, so friends, this minus 1, it becomes integer, and this 0 becomes that comes in whole numbers. So friends, subtraction of natural numbers, subtracting two natural numbers can give us a natural number, or else it can give us 0, or it can give a negative number. So by the arithmetic operation of subtraction, we can get a natural number, or else we can get a whole number, or we will be getting negative integers. So this happens with subtraction. We are moving from only natural numbers to other set of numbers by the arithmetic property of subtraction. Now let us see what happens with our next operation, division of natural numbers. So if you go on for dividing the natural numbers, what you may get? So division of two natural numbers gives us a natural number or a fraction. Just say for example, if I write 4 by 2, 4 by 2, it gives us a natural number. Next, 1 by 2, this is a fraction, or in decimals it is 0.5. So when I say 0.5 or when I say 1 by 2, so this is our set of rational numbers. So division of natural numbers can give us natural numbers or it can give us rational numbers. So friends, remember this particular point. Whenever we are speaking about the mathematical operation division, dividing one natural number with another natural number, we are going to get a fraction. Not always, but most of the time. And when this fractions comes into the picture, we are in the arena of rational. So I hope the things are clear with you as to how the number system changes from addition to subtraction, from subtraction to division. Addition keeps all the natural numbers as natural numbers. Subtraction can take us to whole numbers and to negative integers, and division can again further take us to one more set of numbers which are called as rational numbers. Having understood this thing, friends, then comes one more category, that is irrational numbers. What are irrational numbers? Hippasus, a Pythagorean philosopher, discovered irrational numbers in the 5th century BC. Irrational numbers are those real numbers that cannot be represented in the form of a ratio. So irrational numbers matlab you cannot write these numbers in this particular form. You cannot say it in the form of p by q. It is not possible to write numbers in the form of p by q. Irrational numbers, when written as decimals, they do not terminate and they do not repeat. So one of the important property of irrational numbers is, one is non-terminating and the other is non-recurring. The numbers don't reoccur nor the numbers terminate. So this is one or two of the important properties of irrational numbers. First thing is you cannot write in the form of p by q. Second, they don't terminate. What do you mean by non-terminating? Friends, non-terminating means if I am writing this numbers 5 by 3, so 3 divided by 5, so 3 ones are 3. Next comes 5 minus 3, 2.0, 3 6 are 18, 2 0 6. So this is called as recurring numbers. One more example is 5 divided by 2. Sorry, it should have been 2 divided by 5. 2 2s are 4. 5 minus 4 is 1, 0. So 2 5s are 10. So what has happened? This has terminated. So first thing is, the first example that we saw was 5 by 3. The answer was 1.666 and this is 2.5. So this particular feature is called that of this is recurring and this is terminating. So rational numbers are those numbers which don't reoccur and which won't terminate. Let us see what these numbers are. The set of irrational numbers is expressed as the set of all real numbers. It is expressed as set of all real numbers minus the set of rational numbers. So R minus Q. So backward slash symbol indicates the set which is minus. So the set of real numbers minus the set of rational numbers gives us irrational numbers. Now friends, we have brought into the picture one more number and that is our real. So common examples of irrational numbers are pi. You can see pi is an irrational number and the value of pi is 3.14159265, and here you can see this dot 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 dot. So these numbers won't stop, they go on and on and on. Similarly, Square root of 2 is also an irrational number. So square root of 2 is equal to 1.4.1, sorry, 1.4142135 dot 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 dot. So this number also go on and on and on. Similarly, one more number is Euler's number. Euler's number, that is given by the notation E, and the value of Euler's number E is equal to 2.718281. Another example is of golden ratio phi, which can be written as 1.61 and so on and on and on. So these numbers, friends, when I'm writing it on the number line, so these are the set of pink dots you can see is the set of all natural numbers. Now where this irrational comes into the number line, this particular thing you can see square root of 2, 1.41, then the other pink dot you are seeing is 1.61, that is 5. Here you can see E, Euler number, that is 2.71. This is our pi, 3.14. So these numbers, friends, which are there in red are our irrational numbers. So these numbers become irrational numbers. And when I'm speaking about irrational numbers, set of rational numbers is one particular set and the other set is irrational number. So we are having two sets of numbers now, as you understood. One is all those numbers which are rational numbers, and the other numbers which cannot be written in the form of p by q, they are called as irrational numbers. And this both together becomes our next type of number, that is real numbers. Rene Descartes coined the term real in the 17th century. A combination of rational numbers and irrational numbers are known as real numbers. All numbers except complex numbers are real numbers. Now you can see we are coming into the next dimension. So I am introducing to you the word complex numbers. All numbers except complex numbers are real numbers. So what are these real numbers? Therefore, real numbers are having the following 5 subsets. Natural numbers 1, 2, 3 are real numbers. Along with 0, even 0 is a real number. All negative integers, positive integers along with 0 is also real number. All the rational numbers are also the part of real number, and even the irrational numbers are also the part of real numbers. So on the number line, how we can represent the real numbers? 0, positive integers, negative integers. So you can see pink dots 1, 2, pink dots are natural numbers, yellow dot whole numbers. So pink dots, yellow dot and blue dots all together integers. In between them, if I bring the fractions, all these things together, the rational numbers also becomes real numbers, and I also place the irrational numbers in this number line, and we are having the real numbers line. So all these numbers together constitute to be real. I hope till now it is clear. Now here I introduce one thing to you, that is complex numbers. We will be very soon seeing what complex numbers are. Before that, a summary of all the numbers. Natural numbers 1, 2, 3, all positive set of numbers come under natural numbers. If you bring 0 into the picture, then it becomes whole numbers. If you bring even the negative numbers along with the preceding numbers 0, 1 and 2, 3, you will get integers. In this, if you also include the fractions, you get rational numbers, and there is other set of numbers which we saw, which cannot be represented in the ratio form, that is P by Q. They are all irrational numbers, and both irrational numbers and rational numbers together, friends, become our real. So this is all about the number system up to real numbers. So most of the time in our day-to-day life, we come across, in our day-to-day life, it may be in social sciences, it may be in economics, it may be in commerce, you see this type of numbers. So all these numbers are real numbers. Now moving ahead and saying, then what are complex numbers? As I said, real numbers are all those numbers which don't include complex numbers. So complex numbers, or you can say imaginary numbers, are those numbers which don't fall into this particular area. So friends, these are our real numbers. In the number system, there is the other set of numbers which are called as imaginary numbers. Now the question comes, what are imaginary numbers? So few more minutes after understanding what are imaginary numbers, we'll wind up the session. Friends, what is square root of 9? It is 3. Square root of 5? It is 2.23. Square root of 4? It is 2. You may be wondering why I am speaking about square roots. You will understand. Square root of 2 is 1.41. So you can see, when I want to write the square root of 1, it's always 1. Square root of 0 is 0. So all these numbers, all these positive numbers along with 0, if I am trying to find out the square root, you can see I am getting the answer. Now exactly the mirror image of this, if I want to write 3 square is 9, or square root of 9 is 3. So both are same. You can see here 3 square is 9, or square root of 9 is 3. So these are the different ways. So from squaring the things, you get a number. By finding the square root of the number, you go back to the original number. So this is how it is. Similarly, what is the negative square? If I am writing 3 square, here you can see 3 square is 3 into 3, that is 9. Similarly, minus 3 square, that is minus 3 into minus 3. This is minus into minus becomes plus, and 3 into 3 becomes 9. So you can see both the answers are same. So when two negative numbers are squared, we get positive answer, and when two positive numbers are squared, we get a positive answer. Similarly, the same case with 2 square. So 2 square is 4, or you can say minus 2 square is also 4. So two numbers, same numbers, if you square it, we are getting positive answer. Now comes the tricky part. If you want to find out what is the square root of minus 1, what can be the answer? What is the square root of minus 2? What can be the answer? For this, friends, we'll just see how the answer will come in the calculator. So all these particular numbers that I have written, the square roots, we'll try to say it in the calculator. So here, friends, I am having the calculator, and see what is happening. You can see 9, square root is 3. Similarly, square root of 5 is 2.23. Similarly, square root of 4 is 2. You can see square root of 2 is 1.41. Square root of 1 is 1. Square root of 0 is 0. Now you see, just pay attention. Square root of minus 1, you are finding an error. Similarly, square root of minus 2, again you are finding an error. So, and I see there's this minus 1, square root of minus 1, you are not getting any answer. This question mark is in there because in calculator we are getting error. But when we are speaking about mathematics, there has to be some answer for this particular number. There has to be answer for any number that is negative and we are trying to find out its square. Any number, any negative number whose square root we are trying to find out, the calculator is showing it as an error. So friends, this number we have to imagine. There is some number, the calculator is not able to find out, so we need to imagine what can be the answer of this. Here comes imaginary numbers. So what is the square root of a negative number? You saw square root of a negative number, we were not getting the answer. Which is the number if you square, you get negative value. If any number we square, we saw that we are getting only positive value. But any number if you want to square it, same number and getting a negative value. So these are the two important questions, and to answer these questions, we come across imaginary numbers. Originally it was coined by René Descartes, the person who introduced real numbers, but he brought this particular thing in a very derogatory term, or you can say he regarded these numbers as fictitious or useless. Derogatory matlab, which is very unpleasant word. So later on, the name you can see imaginary came from individuals thinking what it would be like to have a number system with square roots of negative numbers. That is what they were imagining. So imaginary numbers are defined as the square root of negative numbers. Square root of negative numbers, where it does not have a definite value. That is what is imaginary numbers. Now let's see the imaginary unit or unit imaginary number I. So here I am introducing to you one more notation I. So solution of quadratic equation. Now see quadratic equation. This is a quadratic equation. X square plus 1 is equal to 0. Or you can say x square is equal to minus 1. Or you can say x is equal to square root of this x is imaginary. So x is equal to square root of minus 1, and this x is what is called as imaginary number. L. Euler in 1707 to 1783, he introduced the notation that I is equal to square root of minus 1, or you can say I square is equal to minus 1. So friends, the first question, what is the square root of a negative number? The square root of a negative number is I. Or the second question, what is the number if you square to get negative value? If I square I, then what answer I am going to get is minus. So friends, I square is equal to minus 1 or I is equal to square root of minus 1. So these numbers are called as imaginary numbers. I hope it is clear. What is this imaginary numbers? And then one point of addition along with imaginary numbers, and that is our complex numbers. So what are complex numbers? Complex number is the combination of real number and imaginary number. So if I write this particular thing, 5 plus 3i. So in this you have studied 5 is a real number, 3i is an imaginary number, because here I we are imagining it, and both together 5 plus 3i is a complex number. So imaginary numbers and complex numbers, where do we use them in our real life? So most of the time, friends, imaginary numbers and complex numbers are widely used in pure sciences, physics, engineering subjects, mathematics. There we come across imaginary numbers and complex numbers. For social sciences at undergraduate level, the study of real numbers is sufficient. Then you may ask, in social sciences, where we may come across these complex numbers or imaginary numbers? Friends, any economics or finance students taking a higher level course is likely to encounter complex numbers. It is likely to encounter complex numbers when you are dealing with financial models or when you are dealing with higher level of econometric studies. There we may come across complex numbers. So with this, we come to the end of the session of number system. Hope you enjoyed it. Okay, keep practicing. It will be helpful for you in the next theory, because in the initial classes, in the initial session, I was telling you set of real numbers, set of natural numbers, set of integers. So that set what I was telling. Our next class of discussion will be set theory. So till then, friends, take care of yourself, be happy, keep smiling, and soon we'll meet. And thanks for watching Understanding Economics with Professor Aftab. Thank you everyone. Till my next class, take care of yourself. Tata, bye bye.